In chapter 7, we talk about the distribution of the sample. So first we look at the two concepts. One is called a parameter and the other is statistic. So the difference between these two parameters is a numerical feature of population. So that's talking about the entire population. For example, we talk about a population mean and a population standard deviation, population variance. And the statistic is a numerical valued function of sampled observations. So statistic is more about a sample. So we may not talk about the entire population. We pick a few samples and we talk about the mean and the standard deviation or maybe the variance. So it's more like a sample mean, sample standard deviation, sample variance. So that's the difference between parameter and the statistic. So parameters, some examples like population mean, population standard deviation, population variance, and the statistic is sample mean, sample standard deviation, sample variance. Okay, now and so this section we talk about the sampling distribution. So what we have talked about before, when we talk about population distribution. So we have talked about the entire population, how many different values, and for each value, what's the corresponding probability. By this section, we only talk about the probability distribution of a sample. Okay, so of some samples, and so we look at this example. Suppose we have 3 apartment units. First unit has 2 apartments. Second unit has 4 apartments, and third unit has 3 apartments. And if we talk about the random variable, the x as the number of apartments in each unit, and this is the distribution. But this is population distribution because we're talking about the entire population, which is these 3 units. So be careful here. Although we know that population most of the time has a huge data, like a huge set of data, maybe like millions of people or something, the entire population. But in this case, in this example, to make it easy, the population only has these 3 units. So if we look at the population distribution, and we look at the variable, the number of apartments. So if we pick a unit randomly, how many? What's the percentage of the? What's the chance of you getting a unit that has 2 apartments? And we can see we only have 3 units. So if you randomly pick one, and only one of them, one apartment has 2 units. Only one unit has 2 apartments. So that's the probability is 1/3. And similarly, what's the chance of you selecting a unit that has 3 apartments, and which is also 1/3 because there's only one unit, one out of these 3 units that has 3 apartments, and the same for 4. So when you select one apartment randomly from here, suppose you just put these 3 numbers 2, 3, 4 and in a box, and you just randomly pick one from the box without looking, and what's the chance of getting a unit that has 4 units, or what's the chance of getting a number that is 4? So that's 1 out of 3 again, because there are only 3 numbers in there, and only one out of these 3 numbers is 4, and only one out of these 3 numbers is 2, only one out of these 3 numbers is 3. So of course the chance of getting each number is exactly 1/3. So that's the population distribution. And now we are going to look at sample distribution. So sample, we're just going to pick a few. So we're not talking about all 3 units. We just say I'm going to pick 2 units. That's going to be my sample. So it's not like 3 units are the entire population, then 2 units just a sample. And but of course, in real life, we may have like the whole country. We have millions of people, and when we pick a sample, we may pick maybe 1,000 people, and that's the sample. But in this case, because to make the problem easier, the entire population has only 3 units, and the sample has 2 units. Okay, so the first question is to list all possible samples. So if I pick 2 numbers out of these 3 numbers, how many to pick 2 numbers? And again, when we pick a number, it's not like we pick 2 numbers out of it. It's more like we pick one number and we look at the number and then we write it down and then put that number back. So with replacement, we put a number back and then we go to the box and draw another number, and then I record a number again. So in this case, if you put, maybe the first time you will get number 2, and if you put 2 back, the second time when you pick another number, you may still get 2. So 2, 2 is the first sample, and you can do it again and again. So all the possibilities you're gonna get are these 9 different possibilities. So you can get 2, 2, or 2, 3, or 2, 4, or maybe 3, 2, 3, 3, or 3, 4, or maybe 4, 2, 4, 3, and 4, 4. So if you list all possible samples, and that's going to be just the first row. And then we have to evaluate X bar. We know X bar means sample mean. So each of them is a sample. 2, 2 is one sample. 2, 3 is the second sample. 2, 4 is the third sample. So it's kind of like we have 9 different samples. So for each sample, so if we look at the first sample, 2, 2, and we try to figure out the average, which is mean. And how do we do that? Just use the sample mean formula we learned before in chapter 2, and we take you may have different values, x1, x2, xn. So you add all these different values, divide by the sample size. And be careful in the formula. If you look at the formula sheet on the front of the book, it didn't really put a subscript I there. They didn't specify x1, x2, xn. They just put a x. So even in this formula, they put xi. If I get rid of this I, if I don't show you I, sometimes they just write like this. But you don't think there's only one x value. This x can change. So because there's a summation sign, this summation means you're gonna add all the different x values. And so sometimes you don't see a subscript I. You only see x1, x2, you don't see x1, x2, x3, xn. That you only see x. But x doesn't mean just one x value. It means x1, x2, x3, xn. Okay, so that to clarify that. Okay, so we're going to use this formula to find the average, which is very easy. So because in this sample there are only 2 values, the sample size is 2, and there are 2 values. I add these 2 values by using the formula add. You can think of the first value is x1, the second value is x2. So you add these 2 values, 2 plus 2, divide by the sample size 2, so you still get 2. Okay, so that's how I got 2 here. And similarly, you can do the same thing for 2, 3. So you add 2 and 3, you get 5. 5 divided by 2, you get 2.5. And you add 2 and 4. So this is the third sample. 2 and 4, you add and divide by 2. The fourth sample, 3, 2, add and divide by 2, add and divide by 2. So we got all the x bar values. So that is how you evaluate x bar for each sample, because we have 9 different samples. So you have to use the formula 9 times. And then we also need to find the sample variance, which is s squared, the letter we use. So let's see how we do that. And the formula for sample variance we learned in chapter 2 is the sum of all squared deviations divided by n minus 1. And there is another formula, but here we're just going to follow this formula to do the problem. Again, in the formula you see xi subscript here, but sometimes if you look from the page, they didn't put I, they just put x here. But again, x doesn't mean just one x value. It means x1, x2, x3, xn. Doesn't matter how many you have in the sample. So if we do for the first sample 2, 2. Okay, so I'm going to work on the first one, the first sample 2 and 2. Don't look at the others. You have to do it for each sample. So for 2 and 2, I just calculated the average, which is adding these two values divided by sample size 2, which is 2. And then because I have to use the x bar, the sample mean, to do the sample variance. So you take each value, x value, so x1 minus x bar, and square it. So that's the squared deviations plus the second value minus x bar, the average, and the difference, and square it. So we add them. I'm sorry. Again, I need to divide by the sample size, which is 1. So I didn't forgot to put it here, and divide by, because sample size is also 2. So divide by 2 minus 1, which is still 1. So 0 plus 0 divide by 1, you will still get 0. Okay, and then you will. So I put in the table here. Okay, right here. So for 2 and 2, the first row I put all the x bar, the average we calculated before. For s, the sample variance, I put the number I calculated 0 here. And for 2, 3, you have to do it again. So let's look at 2, 3, the sample 2, 3. So the first value is 2, the second value is 3. We calculate the average, that's 2.5. And then you have to do 2 minus 2.5 squared plus 3 minus 2.5 squared. And don't forget, put a divide by 2 minus 1 here, because 2 minus 1 is 1, so I omitted it here. And so it's 2 minus 2.5 is negative 0.5, squared is 0.25, and plus 3 minus 2.5, which is also 0.5, 0.5 squared is also 0.225. Don't forget there is divide by sample size minus 1, 2 minus 1, which is 1, and so 0.5 divided by is still 1. So the 1 here, it's not very easy for me to type the fractions here, so I just omit that, but it's you should do that when you write down your work. Okay, so I found out the sample variance for sample 2, 3 is 0.5, so I put it down here in the table. It's 2.5. And do the same thing for the sample 2, 4. So you will do 2 minus 3 squared plus 4 minus 3 squared divided by 1, you get 2. And do it again for 3, 2, and 3, 3, and 3, 4. So just keep applying this formula 9 times. So you will find the sample variance for each sample. Okay, so that's called sample mean and sample variance. All right, that's how you do this. You can do this for the first part of 7.6. 7.6b determine the sampling distribution. Okay, so we have the sample mean for each one. 2, sometimes it's 2, sometimes 2.5, and 3, 2.5, and so on. So you can look at we're talking about the sample distribution of x bar. So look at this row, second row here. Out of how many different values do we have? We have 2, 2.5, we have 3, and we have 4. And so we make a list of all these values: 2, 2.5, 3, 3.5, and 4. And the probability. So let's look at the number of values. How many 2's do we have out of 9 of them? 9 numbers. So there's only 1. So 1 out of 9. And so that's why we have 1 out of 9 here. And the 2.5, how many of them out of all those different averages? We have 2.5, 2.5, and 2 of them. So it's 2 out of 9. So similarly, you should have 3 3's and 2 3.5's and 1 4's. And that's the distribution for that, and for average. But we still have to do the average for s squared. The sample distribution for s squared. So we do the same thing. So we have number 0, 0.5, and 2. So I write down these 3 different numbers: 0, 0.5, and 2. And how many zeros out of these 9 numbers? So we have 1, 2, 3 zeros out of 9. So it's 3 out of 9. You can reduce it to get 1/3 if you want. And how many 0.5 out of these 9 different sample variants? 1, 2, 3, 4. So we have 4 out of 9. And then how many 2's do we have? 1, 2. So we have 2 out of 9 for s squared. So I use letter F for the probability. F represents probability for s squared. So each variable, you can do distribution, the probability distribution.